All right, welcome to Chapter 7, Section 5, the Triangle Inequality. This is for IM II or Integrated Math 2. So a couple things you'll see on your screen here. The first thing you should see is a due date on your student screen. You don't see it on my teacher preview, but you should see it on your student screen. The second part is attempts. You always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many questions we have on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is the one you keep. Partial credit is always enabled, so if you have one of two questions answered correctly, you get credit for one question, or however many you answered correctly. And then down here it says once you start your homework, you must finish it before you can work on anything else. That means once I click Start, down here in the bottom right corner, I will see the Submit Assignment button, if this ever loads. So we'll let that keep loading while I talk here. So we click the Submit Assignment button. You won't see it on my screen when this finally loads because it's the teacher preview, but once we, on your student screen, you'll see it there. So you want to make sure that you always click that button for two reasons. Number one, it will lock you out of all of your assignments if you just close the screen. It assumes you want to leave the attempt open. Remember, you have unlimited attempts. So click that button so it doesn't lock you out of everything else. It'll save your place too. So if you have a green check mark on, one of the two questions, it'll save that for you. The second reason is it actually affects the grade book, so your teacher can see what you've been working on. Otherwise, it just kind of pauses your account, and it doesn't let you do anything here. So I'm going to reload this because it looks like it's frozen. For whatever reason, it wasn't opening. So let's go ahead and click Start again here. There we go. So the other things we have here are explanation, example, and message center. So explanation literally says you're going to lose your question attempt because it's going to give you the answer to this question. So it's not going to give you the answer and then let you come type it in. Example, it will show you an example of how to complete this problem. So we're going to look at inequalities on this one and take a look here at what we want to do. You can look at another example if you want to, and then you can also message your teacher directly from the screen so we know where to come help you because it attaches a picture. All right, so for this first one, it says for each set of the three lengths, determine if they can be the side lengths of a triangle. So for the triangle inequality, three side lengths can form a triangle if and only if the sum of any two lengths is greater than the third side. So what we need to do is make sure that when we add two sides, it's always greater than the third side. If we find one of those to be false, then it can't be a triangle. So we're literally just going to go through and go 8 plus 6 is greater than 24. 6 plus 24 is greater than 8. And 24 plus 8 is greater than 6. So if any one of these is false, then it's not going to be the side lengths of a triangle. So right away I can tell, well, 8 plus 6 is not greater than 24. So this is not the side lengths of a triangle. So same thing with this next one. I have 15 plus 12 is greater than 4. That's true. 12 plus 4 is greater than 15. Not by much, but still true. And then 15 plus 4 is greater than 12. All of these are true. So only these two were true on the top. But as soon as I find one that's false, I say no. But if they're all true, then it can be the side lengths of a triangle. So we're just testing, can it in fact be the side lengths of a triangle? So we have 4 plus 15 is greater than 16. That's true. 15 plus 16 is greater than 4. That's true. And then 16 plus 4 is greater than 15. So again, they're all three true. So yes. And then we have 9.1 plus 2.9 is greater than 5.4. Well, that's true. 2.9 plus 5.4 is greater than 9.1. Well, let's test that. So we get 9 plus 4 is 13. And then 5, 6, 7, 8. So it's 8.3 is greater than 9.1. That's not true. I don't even need to write the other statement. I know that's not true. So I can go ahead and click check, and we're good to go there. So we're just testing. Is it in fact true there? So the side lengths of a triangle are 10, 20, and x units. We want to find what is the range for possibilities for x. So remember, the two side lengths have to be greater when I add them together. So if I'm looking at this piece here, I'm going to erase this really quick. So I have 3 statements that I want to write. I have 10 plus 20 has to be greater than x. 20 plus x has to be greater than 10. And then 10 plus x has to be greater than 20. So these are my 3 statements. These are my 2 sides greater than the third side. So this one I have 30 has to be greater than x. And then if I look at this one, I want to solve for x, so I'm going to subtract 20 from both sides. 20 minus 20 cancels. I have x is greater than negative 10, because 10 minus 20 is negative. Well, I'm not going to have a negative length, so I'm actually going to ignore this one. And you're always going to ignore one of the 3 because it'll end up negative. So this one I have minus 10 on both sides. 10 minus 10 cancels. X is greater than positive 10, which is okay. So now what I want to do is I want to put this into one statement, because I don't want to have 2 different statements where x is greater than or less than a number. So I'm going to put x in the middle. I'm going to put them in order from least to greatest, like this. And I want to make sure whatever this was open to in the first place or pointing at, I can look at it either way, it's still pointing the same one. So this one is pointing at 10, right? So I'm still going to have it pointing at 10 like that. So I kind of flipped it around. And for 30, it's open to 30. So I still want it to be open to 30 there, like that. So this is the statement that I want to make on this one. 10 is less than x, which is less than 30. So I have 10 is less than x, which is less than 30. So it can be anywhere. Oops, and I didn't put the x in there for some reason. Why isn't it letting me type the x in here? Use x only once. I am using x only once. Oh, it didn't want a capital X. What a silly program. I was arguing. I had my cap locks on. So it didn't let me type in the capital X because it wants a lowercase x. So anywhere between 11 and 29 will work. Or it can even be 10.1. It could be 29.9. Anywhere in between. It just can't be 10, it can't be 30, but it can be anywhere between 10 and 30. And that would work just fine. All right, so that was section 5. I will see you in section 6.